All right, let's talk about oxidation and reduction reactions. So what is this all about? Oxidation and reduction refers to the transfer of electrons from one atom to another. Remember, there are two major types of bonding we've talked about in this class. There's covalent and ionic bonding involves the transfer of electrons from one atom to another. So this is going to be something we see in any kind of reaction that produces ionic compounds. So remember that ionic compounds are generally formed by the reaction between metals and nonmetals. And what we tend to see is that metals and nonmetals they stick together because metals tend to make cations, nonmetals tend to make anions, so opposite charges attract. So what that means is when we see this, we will tend to see reactions between something where one thing gains electrons and one thing loses electrons. So let's look at this example right here. Sodium reacts with chlorine to make sodium chloride. Now this is pure elemental sodium. How do you know that? Because it's just sodium and nothing else. This is pure elemental chlorine, remember, diatomic element. And then they react to make this solid, which is what we typically call table salt. Consider something. All pure elements have a charge of 0, neutral. Doesn't matter what element it is. Pick any random element anywhere on the periodic table. If it's neutral, it has a charge of 0. However, that is only true when it is the pure element. This is also pure element because it's only one kind of atom in there. When it is compounded with something else, when it's part of a chemical formula, it no longer is said to have a charge of 0. It now has a charge of some kind if it's an ionic compound. So what do? We consider, okay, we can actually keep track of the charges. We say the pure element has a charge of 0. We go look up sodium on the periodic table. Sodium is a +1. Go look chlorine on the periodic table. Chloride ion makes a -1 charge. So we can say the charge of sodium changed from reactants to products, and the charge of the chlorine also changed from reactants to products. So we can look at that and figure out what happened, because consider this. If you start with a charge of 0 and end with a charge of +1, you have to think, did you gain or lose electrons? If you gained electrons, you're adding negative charge, which makes it more negative. If you're taking away electrons, you take away negative charge, which makes it more positive. So if we take away an electron, that would turn it from 0 to a +1. If we add an electron to the chlorine, that would take it from 0 to -1. So that is how we can say this. By tracking the charges, we can track which gained and which one lost an electron. Again, the reactions we're presenting in this class will always involve one element gaining an electron and one element losing an electron. We won't present you the ones where like 2 gain or 2 lose or something like that. So this is kind of how we can figure out what's gaining, what's losing electrons, and keep track of where the electrons are going during these reactions that produce ionic compounds. Here's another way of looking at it. If the sodium lost an electron and the chlorine gained an electron, we can basically say the sodium gave an electron to chlorine. It's basically the same kind of idea. So we can look at magnesium reacting with oxygen and do the exact same thing. All right. In fact, you should be able to tell me, what is the charge of a pure element to magnesium or the pure element to oxygen? Do so now. Hopefully you said charge of 0. Now we look on the periodic table and you look at the charge of magnesium and oxygen. That's +2 when it's an ion, that's -2 when it's an ion. So again, you look up on the periodic table. And then we need to keep track of, again, which one gained electrons, which one lost electrons. So we go through the same thought process again. We notice magnesium changed from 0 to +2. Oxygen went from 0 to -2. Therefore, magnesium must have lost electrons. Oxygen must have gained electrons. Which is going with our tendency. We do usually see nonmetals gain electrons and metals lose electrons. Not always, but it is a tendency. And because it's from 0 to +2 or from 0 to -2, that's why I said 2 electrons here. It's because if you gain 1 electron, your charge is -1. If you gain 2 electrons, your charge is -2. Gain 3 electrons, charge is -3, etc. We can do the same sorts of things with these other ones, right? So we can look and see what the charge of each thing is. So Right now you should be able to say, what is the charge of this? Answer now. Okay, hopefully you said 0. What is the charge of this? Answer now. Hopefully you said 0. What is the charge of lithium in this compound? Hint, look at your periodic table. Hopefully you put +1. What's the charge of fluoride ion? Hint, look at your periodic table. Hopefully you said -1. So again, fluorine went from 0 to -1, lithium went from 0 to +1. You should now be able to say which one gained and which one lost electrons. Do so now. All right, if you did so correctly, you said that fluorine going from 0 to -1 gained electrons, and that the lithium going from 0 to +1 lost electrons. There you go, or technically 1 electron, but you get the idea. Now, not only do they always look like this, but consider that you won't always have something going from 0 to something or from something to 0. Consider this iron. Look, it starts as a +3 and ends as a +2. That's still a change in electrons. If you change the charge, it's because you changed the number of electrons. But did it gain or lose electrons? Well, let's look at it. So the iron went from +3 to +2. So do you add an electron to make it less positive, or do you subtract an electron? Well, adding an electron adds negative charge, and that would indeed pull it down from +3 to +2. So I'm going to say the iron gained an electron. And the iodine went from -1 to 0. So in this case, the iodine, it lost negative charge. So it went from, that's how it went from -1 to 0, so we say it lost an electron. So remember, I said earlier, metals tend to lose electrons, but it's not always the case. This is an exception. Don't depend on generalities too much. You have to look at the specific situation. All right, let's get this out of the way. I've been talking about gaining and losing electrons all this time. This is the proper words that describe gaining and losing electrons. Okay, as mentioned at the beginning. Oxidizing and reduction are the words you need to know, and be familiar that oxidize means losing electrons, reduce means gaining electrons. So this helps. I think there's something I'm going to hand up to write this down, so go and fill in whatever you've got. But it helps people to remember Leo says gur, because loss of electrons means oxidation, gain of electrons means reduction. All right, hopefully that helps. So you should be able to look at these and figure out which one's gaining electrons and figure out which ones are losing electrons. Let's do just a couple for practicing. Right, potassium from 0 to plus. So we have to think, do you get from 0 to plus by adding negative, or do you get from 0 to plus by removing negative? And you get this by removing negative. So we would say from 0 to a plus charge, this potassium got this by removing an electron. And if it removed an electron, we remind ourselves that losing electrons means oxidized. So this is oxidized. We can do the same thing with this lead up here. So the lead +4 goes to lead +3. We have to think, do you get that from adding negative or subtracting negative? And the answer is you get that by adding negative. So that means you're adding electrons. And when we look at this, reduce means gaining electrons. Right, it's a little counterintuitive that gaining something is referred to as reducing, but it has to do with the fact that when you add electrons, it reduces how much positive charge there is. Because look, let's reduce it as less positive charge. Maybe that helps. Okay, so there's a few others. Let's do another one just for example. Remember, pure element is 0 charge, it's neutral. So from 0 to -1, it gained negative charge, meaning it gained electrons, it is reduced. Okay, hopefully you're catching on to the pattern of this. Go ahead and try this one now. All right, hopefully you said that it gained electrons, making it reduced. Try this one now. Okay, hopefully you said that it went from 0 to minus charge, meaning it gained electrons and was reduced. All right, all these other ones, you start neutral and either positive or negative. This one, you start with a charge and end up neutral. So you have to think, you go from a -3 charge to a charge of 0. Are you adding negative charge to go from -3 to 0? Or are you removing negative charge and go from -3 to 0? Make a choice now. Hopefully you chose that you lost negative charge, which means losing electrons. And we look up here, that's oxidized. Okay, so that's how I would answer that one. All right, now let's look at some other things. Other examples. So that was one way you could see it on the exam. Here's another particular potential way. Here we just give you an entire equation. So this does look a little different than the other ones. You saw some simple synthesis ones there. This is a single displacement reaction. And here's the thing, remember, what you gotta do is figure out the charge of everything and then figure out what gained and what lost electrons. Now, we're gonna make some assumptions here. We still assume that the charge of a pure element is 0. So this is a charge of 0. This has a charge of 0. So in this case, you have something with a 0 charge in the products. Now, what about these things? And the answer is that for these ones, these polyatomic ions, we're going to assume they remain the same. They're just going to be like nitrate's a -1, and we assume it stays as a -1 the whole time. We're going to assume it's the metals that are changing, because if it was the nitrate, then you'd have to get, well, it's the nitrogen, it's the oxygen, and it gets complicated. So we're just going to assume it's the metals that change their charge. And they are able to do that most readily. So here's the thing, guys. If nitrate's a -1, silver's a +1. If you didn't already know the charge of silver, that's how you could have figured it out. Okay, silver's a +1 charge here. And that's in general what charge is going to be. Now, for copper with a variable charge, same thing. You got to be like, nitrate is a -1, therefore the copper must balance out being a +1, because it's 1 nitrate, 1 copper. So there we go, the copper must be a +1. So we say, okay, what happened, your copper became copper with a +1 charge. Your silver started out as a +1 and turned into a neutral atom. And then your nitrate started with a -1 and ended still as a -1. So the nitrate did not change. We're going to ignore it from our considerations. And then we're just going to look at the things with the charge that changed. So we're going to look at this one, say the copper, when it lost negative charge, which means it lost electrons. Remember, Leos is Guru, so loss of electrons is oxidation. So we say the copper was oxidized because it lost electrons. And then the silver went from plus to 0, so it must have gained negative charge, it must have gained electrons, which means if it gained electrons, the silver got reduced. Okay, so that's going to be our conclusion. Copper oxidized, silver reduced, and then this is the part that was animated in there, and I'll remove all this so it's more easily visible. But that's how I would reach that conclusion. The conclusion presented here, and this is the format that we usually have students copy down. All right, so let's look at some more examples like this. All right, so, I should back up and say, metals tend to gain electrons. Metals tend to lose electrons, but you'll notice one metal gained and one metal lost. So it's, again, generalities are not always going to be followed in all examples. All right, so let's go ahead and have people, people should be able to do this one. So go ahead and have a look at it. Can you tell which one got oxidized, which one got reduced? That means figure out which one gained electrons, which one lost electrons, and then attach the appropriate label. Go ahead and try it now. All right, welcome back. Hopefully you got this for an answer. Why? Because charge of 0, neutral, neutral. This is a +1, this is a -2. So from a 0 to a +1, this potassium must have lost negative charge, which means it must have lost electrons, and losing electrons is oxidized. Oxygen must have gained electrons to get a negative charge, which means gaining electrons is reduced. So that's why that was said. All right, which one was oxidized, which one was reduced? Now, we've looked at metals for all of our examples, but bringing this one in here is a good way to show that it's not necessarily just metals that get oxidized and reduced. Because consider we have, what do we have? We got copper, hydrogen, and NO3 on both sides, so that's nitrate. So we have copper, we've got hydrogen, and we've got nitrate. Now copper, remember, this starts with a charge of 0. And then here's a pure element, so that's a charge of 0. Remember, nitrate's always a -1. We're going to, polyatomic ions, we're going to leave them alone. We don't mess with those. Unless their formula changes, you don't mess with them. And they're both NO3s. Now, I'm aware there's 2 NO3s here and there's 1 NO3 here, but that doesn't change anything. It's NO3, NO3, so leave it alone. All right, so that just leaves the hydrogen and the copper. So what do? The hydrogen is always either +1 or -1, because at the beginning you know it's a cation, it's a +1. And then for the copper, what's the charge of the copper? Well, each nitrate's a -1. There are 2 nitrates for a total charge of -2. Therefore, the copper must balance out being a +2. So what we're seeing here is that, okay, copper is a +2 at the end. So what happened? Copper starts neutral and turns into copper +2. Hydrogen starts as a +1 and turns into neutral hydrogen. I guess I could put H2, it doesn't really matter. If I want to be a little more accurate and persnickety, I could do that, but it doesn't really matter. We're just tracking what happens to the electrons. We're not even counting how many. And then finally, we're saying nitrate starts as a -1. Oops, I make a better arrow right there. And then ends as a -1, so we leave it alone. We're going to not even consider it in this. All right, so this is what we do, is we keep track of the fact that, yes, some nonmetals such as hydrogen will potentially be involved in this sort of thing as well. Well, ladies and gentlemen, you should be able to tell which one got oxidized, which one reduced. Do so now. All right, hopefully what you said was that copper becoming a +2, that is the loss of electrons, and loss of electrons is oxidizing. And then from plus to 0 is gaining electrons, and gaining of electrons is reduction. Or I guess I could have put reduced to get the idea. All right, so that's what people should have had, and here's the final conclusion. Copper was oxidized, hydrogen was reduced. And, well, there we go, ladies and gentlemen. That's your overview of how it works with oxidation and reduction.